Hey everyone, this is Mohammed Nadeem and welcome to my YouTube channel. Today in this lecture, we will discuss in more detail about the elastic modulus. Elastic modulus is the property of the solid material which enable us that how much this specific solid material is the response to external force. So by applying the external force, there will be change in the length, in shape or in volume of that specific material. So how much change occur in the dimension of that specific material is described as by the elastic modulus, which is constant for that specific material. So first, what is the elasticity? Elasticity is the property of the material which regain its original shape, length or volume when the external force is removed. So this property is called the elasticity, and the object which regains its original dimension when the external force is removed is called the elastic object. On the other hand, we have plasticity, which is the property of the material which do not regain its original dimension when the external force is removed is called the plasticity, and the object is called the plastic object or the plastic material. uh, Elastic modulus is the actually the ratio of the stress to strain within the elastic limit is called the elastic modulus. Now, what is the stress? Stress is actually the force per unit area. So if we exert some force on a specific solid material having some area A, so if we exert the force on that material, there will be change occur in the dimension of that material. So the force per unit area is called the stress, and the change occur in the dimension of that solid material is called the strain. So within the elastic limit, the ratio of that stress to strain is called the elastic modulus, and elastic modulus is constant for a specific material. This is the formula for the elastic modulus, which is equal to the ratio of the stress to strain. The change occur in the dimension of that specific solid material is of three types. So therefore, this elastic modulus is also have three types. The first one is the Young modulus. Within the elastic limit, the ratio of the tensile stress to tensile strain is called the Young modulus. So by applying the external force on this area, let's say on this area A, if we apply this force, external force, so there will be change occur in the length of this the rod of the metal. Okay, so this change occur in the length is actually contributed by the by the stretching of the bonds between the atoms or between the layers of the crystals. So within the elastic limit, this stress is actually the force on this area is called the stress, and the change occur in this case the change occur in the length. Okay, so how much change occur in this length is described by the strain. So if we divide this stress by the strain, it will give us the modulus, and here the change occur in the length of this solid material. So therefore we call this as a Young modulus. Consider a rod of length L. Okay, so it has some length L and cross section area of A. When call it at one end and subjected to a force perpendicular to the cross sectional area, the rod will be stretched to a new length, which is actually L plus del L. Okay, so the change occur this is actually L, and now it here it become L plus del L. So the change occur here is the this del L. Okay, so the there is the internal forces present between the atoms in the form of the bonds. Okay, so if we apply the if we apply the force, so this metal consists of the large number of the atoms, and the bonds between that atoms will be stretched, and due to which the length of this solid material has increased. So what is the tensile stress in this case is the ratio of this force, okay, the ratio of the force exerted on this material to this area. So force per unit area is called the tensile stress. So how much change occur in the length of this material is described by the tensile strain. So here tensile strain is the change in the length of this material to the original length. Now, the young modulus is actually the ratio of the tensile stress to tensile strain, and tensile stress is given by F divided by A, and tensile strain is given by del L by L. So this is actually the young modulus. Its SI unit is Newton per meter square, because here this L and L will be cancelled, the units of these will be cancelled, and only Newton per meter square will be left. Okay, a young modulus follow Hooke's law within the elastic limit for a small strain where the relation between the stress and the strain is linear. Bulk modulus here is actually the change occur in the volume of the solid material. So this is actually that original solid material, and if we apply the external force on this solid material from the all sides, this solid material is consist of the large number of the atoms. Then there is the interatomic distance or the bonds present between that atoms. So if we apply the external force from the all dimensions, that bonds will be compressed, okay, and the atoms will come together near to each other, and so therefore the overall effect will be present on this material, and due to which the volume of this material will be decreased. So this decrease in the volume of the solid material with respect to the external force is described by the bulk modulus. So first is volume stress is actually the force from all dimension on this material divided by the area A is called the volume stress. The strain on the other hand, we have the change in the volume with respect to that original volume is called the volume strain. And we know that bulk modulus is actually the ratio of that volume stress to volume strain. Okay, volume stress is given by force per unit area, and volume strain is given by the change in volume divided by the original volume. So here if we consider the fluid, okay, the this force per unit area is called the pressure for the fluid material. Okay, so for that, the force per unit area, we will put the pressure. Okay, pressure for the fluid material. For the fluid, uh, this volume stress. Okay, this volume stress is also is referred as the pressure. So here, this volume stress is replaced by pressure del P. So divided by the strain, which is actually del V by V. Here, this del P is actually the change in the pressure. Okay, this is only in the case of the fluid. Here, this negative sign indicates that an increase in the pressure and increase in the pressure result in decrease in the volume. Okay, so if we increase the pressure, the decrease occur will be in the volume. we have the shear modulus. In this case, if we apply the force, the opposite force on the material, let's say if we apply the force, one force on this material on this side, the other force on this side, let's consider this book, and on the top of the book, we apply the force on this side. In this way, and on the bottom we apply the force in this direction, so there will be change occur in the shape of this material. So how much change occur in this shape of the material when we subject the external force on this material is described by the shear modulus. So here let's say this is the original shape of this material which is here. Okay, so if we apply the external force on this material, it will displace by del x. Okay, so with respect to that original position, it now making an angle theta. Okay, now this angle theta is actually that strain in this material. So the shear modulus is actually the ratio of the shear stress to shear strain. Okay. Now, what is the shear strain? Shear strain is actually this theta. Shear strain is actually that change occur in this shape with respect to the original shape is described by the shear strain. So this del x divided by this y is called the shear strain. Here, this is the theta. Okay. The adjacent side of the theta is the cos theta, and the perpendicular side is the sine theta. So tangent theta is actually the perpendicular divided by this base. So this perpendicular is equal to del x, and this base is equal to y. So therefore, I have written instead of this shear strain as a tangent theta. So where this angle theta, okay, is very small. Okay, so therefore tangent theta is equal to theta. So the shear modulus is now is defined as the ratio of the shear stress to the shear strain, which is equal to shear stress is actually given by the force per unit area, this force per unit area of this material divided by this shear strain, okay, which is actually del x by y. So this is actually that shear modulus. The elastic modulus of the material is only associated with the solid material within the elastic limit. So if we exceed the elastic limit, there will be no concept of the elastic modulus of the material. Okay. So within the elastic limit, the Hooke's law is followed, and Hooke law is state that the stress within the elastic limit is directly proportional to the strain. Okay, so here is that stress is direct proportion to strain with the constant K. Okay. So here this K is proportionality constant and called the modulus of elasticity. Okay, this is the proportionality constant and called the modulus of elasticity, and which is constant for a specific solid material. Each solid material have their own modulus of elasticity. So let's say this is the material which is the aluminum. It have some young modulus. Okay, it means that if we apply the external force on this material having some area A, the change occur in the length of that material is given by this. The change occur in their volume will be denoted by this, and the ratio of the stress to strain, shear stress to strain, shear strain is given by this value. So for each element, okay, for each material there is a specific young modulus. So there is a specific elastic modulus. So here, therefore, I say that the elastic modulus is constant for each and every material. Okay, So here this expression is called the Hooke's law. Hooke's law uh, hold true for the most material within their elastic limit, where they exhibit a linear relation between the stress and strain. Okay, so if we apply the external force on a specific material, okay, there will be change occur in the length, shape, or the volume of that material within the elastic modulus, so elastic limit. Okay, so Hooke's law is only valid up to elastic limit. However, some material do not follow this linear relationship and exhibit a nonlinear behavior under the stress. Okay, so they within in that case that will not follow Hooke's law. Okay, Hooke's law is only applicable when there is a direct relationship between the stress and the strain. Okay, the uh, practical a demonstration of this Hooke's law is that if we apply the external force on specific material having area A, there will be change occur in the length of there will be change occur in the length of that material. That change occur in the length of the material is actually come from the stretching of the bonds of the atoms present in that materials. Okay, so if we apply more force on that material, okay, so their stretching will be more. Okay, and there will be some elastic limit beyond that. If we apply the external force, this stretching uh, will be more, and the material will do not regain to its original shape, and this will go beyond. That will not follow the Hooke's law. So this was the explanation about the elastic modulus, and that's it, guys. Thanks for watching.